So I suppose what we're trying to understand are some of the principles that control the way fluids move through these complex heterogeneous rocks. And for example, in the area of carbon sequestration, there's a lot of interest at the moment in understanding where the carbon dioxide travels once you've pumped it into the ground. It's less dense than water, and so if you put it into a deep aquifer, the CO2 will typically rise towards the top of the aquifer and then may start spreading out laterally along the aquifer. But as well as that, there's capillary forces. The CO2 is not miscible with water, and so you tend to trap some of the CO2 as it propagates through the formation, so that the trailing edge of the CO2 plume as it moves through the rock will leave a little capillary wake. Understanding how that capillary wake grows and if you like, depletes the plume of CO2 is very important, because that gives you an idea about the ultimate location of where that CO2 will be once you've injected it. And then there's issues about how the CO2, or whether the CO2 can dissolve into the water, and the sort of flow patterns that may develop if that happens, because if the CO2 dissolves into water, the water becomes denser than the water, and it may then start flowing convectively under gravity through the formation. So in all those models, we're trying to understand the principles to get an understanding about the long-term fate of the system. So industry will, I guess if this becomes a big activity, they'll be injecting CO2 for tens of years into a formation. But then you want the CO2 to remain in the subsurface for tens of thousands of years. And so it's really a question of trying to understand what you can learn from the measurements and monitoring that occur while you're injecting, and then see what you can learn about the long-term fate. And of course the physical processes are different when you stop injecting. In the context of oil production, a lot of new oil reservoirs have much more complex geological structure and formation, and more heterogeneous than some of the early reservoirs. And all the oil that remains in reservoirs is actually trapped in more difficult parts of the reservoir to recover the oil from. It's interesting, I guess, if you look in the North Sea, initially a lot of the reservoirs were developed there with the plan of recovering about 25 to 35% of the oil in place. Once that's recovered, there's still a lot of oil left, and there's a lot of difficulty in recovering that additional oil, because the rock because it's so layered, if you pump water through the reservoir to try and displace the oil, the water tends to flow through the path of least resistance. And once those layers are swept of oil and flooded with water, there's different approaches that you can use to try and sweep other parts of the reservoir by adding polymers, or adding other, or drilling infill wells and so on to try and displace the remaining oil. But actually understanding how the oil moves and how the whole water-oil interface migrates to the rock is one of the very challenging problems. And so some of those issues are described in the book as well.